Hello everyone, my name is Jessica. I'm a developer on the taskflow project. Taskflow is a task management library. Right now you can see the code over on StackForge. All the latest stuff is on there. We also have all of our stuff on Garrett too for new code reviews, stuff like that. Feel free to check any of that out. We also have a wiki over on OpenStack, and it has all the information you're going to want for taskflow on there. Cool stuff. So, like I said earlier, taskflow is a task management library. Right now it consists of two basic primitives, a task object and a flow object. A task object is a lightweight unit of execution. It has two functionalities. It has an apply and a revert. Pretty straightforward. Apply is what the task does, and revert is a method that undoes the task. So if your task is create server, your revert would be tear down server. Pretty straightforward. The other unit of execution we have flows, which are a way that tasks are wired together. Flows are capable of running tasks. They can be stopped, resumed, and rolled back. Each flow also is designed on top of a pattern. All the currently available patterns are on the wiki. You can see them right there. The pattern I'm going to be talking about today is the distributed pattern. I just want to iterate, though, that each pattern uses the same syntax, the same taskflow syntax. So if you know how to do one, you know how to do them all. So it all looks the same to the user, it's just the backends that are different. So with that in mind, let's go ahead and look into distributed. The first thing I want to cover in distributed is a tool it's using called Celery. I have a wiki for that written up. It's a quick overview of Celery. You can go check out their documentation though for the project. It's much more robust than what's on the wiki. This is just for, if you have a couple minutes you want to look over it. Okay, so Celery is an asynchronous distributed task queue. So this is what the architecture looks like. Nothing too complicated here. You have your application, you run a task in the application, it posts the task to this message bus. Any worker listening to that bus will pick up the task, execute the task, and return up through the bus to the application. Some cool things about the workers. Each of the workers has failover built in, so if a worker goes down halfway through processing a task, it knows to release the lock on that task, repost the task to the queue, and let another worker pick it up. Workers can also be hosted anywhere as long as they point back to this queue. So you can imagine, maybe you want to dedicate some hardware to workers so you really have some processing power on those tasks. Completely doable, even encouraged. You don't always have to run your workers in the same place you're running your application. So moving on down here. So one of the main concerns with asynchronous or distributed type systems is that they are difficult to debug. Cool thing about Celery is it has all sorts of stuff built in. You can debug queues, workers, clusters, tasks, and it lets you see all sorts of stuff. And it kind of congregates into this tool called Flower. Anything Flower does you can do through the command line. It's just nice to have a UI on top of stuff. It groups everything together. It's really powerful. We will get to see exactly what it's capable of in a little bit when we do some examples. But quick overview, it lets you look at workers, tasks, your queue. It combines everything into graphs for you. That's what you're into. It lets you tear down, bring up workers, see when tasks are executing, what workers are executing, what tasks, all sorts of stuff. Again, we'll get to see that in a minute here. So let's go on over back to distributed. Here we go. Here is a quick architecture overview. Celery plugs into this as the task processor for distributed. Anyway, so the main difference that distributed has from a traditional workflow pattern is that distributed is completely event-driven versus a traditional approach where tasks are in charge of calling their children tasks. Tasks in distributed are not going to fire off unless they receive some sort of notification. And there are two types of notifications that a task can receive. The first type of notification is a data notification. Basically all that is it's saying, hey, this data is now available. And the second notification is a task notification. So you can imagine you have a task that needs to kick off after another task. It doesn't care about the data that that task provides. It just needs to know that that previous task is now in a success state. So that is also one of the notifications included in here. So I guess the easiest way to kind of understand this is let's just follow a task through the distributed system. So we have our task right here, and our program says, all right, I want you to run this task. It's going to post this task to the message bus. These workers listening on the queue are going to pick up that task, process it, and the distributed pattern has event listeners registered to this queue right here. And what those event listeners are doing are they're listening for these signals that Celery sends off. Those signals can be a multitude of things. The ones we're concerned with for distributed purposes are task success and task errors. So let's say we post our task, worker executes the task, it completes successfully. It's going to send off this signal saying, hey, task is now available, or this task is completed successfully. Our distributed client up here is going to receive that signal. This client is in charge of keeping the relations between tasks and sending out notifications based on those relations. So our task completes successfully, our client gets that signal. What this client is going to do is it's going to set notifications to this queue for all interested parties. So if we have task B, which depends on task A's provided data, the client's going to say, hey, task A data is now available. Whoever's interested, here it is. And so task B is going to get that data. If that's all it requires, then it's going to go ahead and it's going to start executing. In the same way, we can send a signal saying task A is now in success state. Task B sees that it's in success state, and it now executes. Again, this will be a little more clear when we get into some examples later. You can see those notifications firing off. Coming down here. I guess the next question that comes up is why a distributed approach over a traditional approach? Distributed offers all the same things that traditional does. First off, it's deterministic. What that means is that we have all these relations defined before a workflow runs. So if you wanted to, you could sit down, go through those relations, and actually draw out the graph of your workflow before it executes. And that provides the ability to do pre-processing on your workflows if you want to, check for errors beforehand, stuff like that. But the cool thing about distributed is you don't necessarily have to do that if you don't want to. The reason that's okay is because distributed gives you the ability to modify a workflow while it's running. So let's say, for instance, you didn't have time to pre-process your graph, whatever, and you introduced a cyclical dependency. Well, in traditional taskflow approach, you'd have to stop the entire workflow, restructure it, and then kick it off again. In distributed, it's as easy as saying, either, hey, remove this task, or in this specific case right here, just say, task 3, I no longer want you to provide data that task 1 requires. It just removes this relation right here, and you do that while the workflow is running, continues on. You could think of this being useful, well, it is useful in a lot of cases. One example is you have a very long running flow. Let's say you have a 3-hour long flow and you get to 2 hours and 45 minutes and something goes wrong. Well, you don't want to stop. Well, taskflow gives you the capability, if you chose to do so, you could have it automatically revert the entire flow. So you get to this breaking point, something goes wrong, taskflow has the capability of automatically reverting the entire flow. But you can imagine if it's that long of a flow, there might be times when you don't want to revert the flow. You want to let it hang, give you the chance to manually go in and fix it, and then have the flow continue on. So for instance, you get to 2 hours, 45 minutes, and your task is create server. And for some reason, that server doesn't spin up. So you can manually go in, you can kick a server, and you can send out a notification saying, hey, create server task is now in success state, and create server IP address is now available. That data is available. And the flow will immediately pick up from where it left off with the provided data and continue on to completion. It's very handy. We'll see an example of that in a second. Also, one of the other cool things you can do with distributed is create persistent workflows. So you can intentionally have a cyclically dependent graph. For instance, this might be useful if you want to set up some sort of cron-like job. Let's say you want to pull data from a server every 2 hours. You can do that in distributed, and you can have every 2 hours have this task pull data from this server and send it to this logging center, something like that. And let's say later on you wanted to add some additional monitoring onto that. Every 2 hours, pull this data, send it off for logging, but I also want you to send it over to this node for some additional processing. You can add that job on there. You don't have to stop your monitoring process. You can continuously keep it going. So cool stuff there. I think that about covers it for right now. Again, this is all on the wiki if you want to go look at this. Let's go back over here. So I guess the next step here is to show some examples. So let's go over to this. I'm going to start up a Celery worker right here. This Celery worker is running in my local environment. I'm going to kick off Celery or Flower as well so we can monitor that. Okay, so let's go over here. Oh, and I'm running my Celery worker in the foreground. You can run it as a background process if you want to. I'm just leaving it in the foreground right now so we can see some events firing off. So let's go and refresh this. Okay, so we can see our worker is online. We can go and inspect this worker. We can see what process it's running on, how many tasks it can handle at one time, what broker it's connected to, what queues it's listening to. We also have control to manipulate the worker on the fly. We can change the pool size, which is how many tasks do I want you to execute at one time. Auto scaling workers, cool stuff. And if we go back over here, we can also tear down a worker. We can restart a worker. Cool stuff on there. Yeah, there's a lot more debugging stuff, but we'll get to that in a second. So let's go back over here. Got this. So I've already defined some workflows for us to run through in the examples. Oh, let me clean this up a little bit real quick. Sorry about that. Okay, so the first flow I have right here. Let's spend a minute real quick and kind of go through the syntax of taskflow. So first thing I've done is I've imported distributed flow as my pattern. Creating a workflow is as simple as giving it a name, telling it to initialize. So now we have a workflow, and I'm defining tasks right here. So these are where your relations are set up. So each task decorator has a requires and provides input, optional input. And what this is doing is it's saying this task add provides add data. And we can see in this multiply task, well, this multiply task requires add data, and it provides multiply data. Pretty straightforward. And so you can imagine if you wanted to go down and map out those relationships, you could map out the flow. And what this flow is going to be doing is it's going to have add as its root task. When add executes successfully, it's going to call multiply and subtract. And then when those have successfully executed, divide is going to fire off with that required data. All you do is this right here. I'm sorry about this. You can just ignore this. It's still a work in progress, and it's a little bit of hacking right now, but let's pretend you didn't see it. So right here, this is what the syntax looks like. You just add the task to the workflow, right? Pretty straightforward. Here's your task. Here's your flow. Add them to the workflow. So we're going to go ahead and import that real quick. Flow equals task.create. Okay, and to run a flow, all you do is you call run. The first parameter run gets is a context object. You can use that. It's persistent throughout the entire flow if you need to pass some stuff around. We don't need that for this particular example. It's pretty basic, so we're just going to leave that as null right now. And the other parameters are what we are going to be using in our flow. So the root task is add, and it requires x and y. So our x and y are going to be 1 and 2. So let's go ahead and kick it off. I put some sleeps in these tasks as well so you can kind of see the dependencies. So add is completed successfully. Subtract and multiply are now executing with adds data. We come back over to our UI, and we can see that task add has in fact completed in a success state. This is its result. Let's go back over here. Subtract is now done. So we see this. Subtract is now success. We go back over here and you can see that task divide is still waiting. This is just some debugging stuff, by the way, within the taskflow code. But you can see that listeners of subtract have got notified with the result from subtract. And since multiply was a listener, it since divide was a listener, it got that information, but divide didn't have the information from mult. So you can see this line right here, task divide is still waiting on multiply input. And then multiply completed successfully, and then nothing's listening to dividing, but if there had been things listening, you know. So cool stuff there. So you can see everything getting notified and waiting for all the available data before it kicks off. Let's go back over to Flower. We can see all of our tasks that have completed successfully, and let's go and inspect a task. So all sorts of information available here. You can see what arguments were passed into the task when it was ran. You can see what the result was. It also gives you, this is how long the task took to run, when was the task started, when did it reach a success state, and what worker ran the task. We go back over to our worker. We can see that these are the tasks that it processed. It's processed each of them one time. So you have a really deep level of insight into this, or into exactly what's going on when it's going on for debugging purposes. It's really, really thorough. So let's go back over here. Oh yeah, and then I also have a Rabbit pulled up here just so you can kind of see the notification system, how this is working. We have our event listeners over here, and then these are the things that are listening to add, these are the things listening to subtract, and multiply in there too. So it's just a quick little, hey, listeners really are getting spun up. So let's go back over here. I'm going to do a quick cleanup of my environment. Okay, and we're back. So the next workflow we're going to cover is when I talked earlier about when a task breaks and we want it to hang and have the option to manually advance it, that's what we're looking at right here. So this workflow, same thing, we're still doing math, provides add data. This multiply requires add data, but unless it gets 2 in for that add data, it's going to throw an error. If it does get 2 in, it is going to successfully return the multiply data, and divide will kick off. So let's go ahead and import this. Whoops. Okay. Same thing, don't need a context object, and add takes 2 parameters. So let's kick off our workflow. We're going to come back over here, wait for add to finish, and oh no, error got thrown. So 1 plus 2 is in fact 3, and 3 is in fact not equal to 2. So our workflow has broken. Let's take a second real quick and go over into Flower and inspect what an error task looks like. So when a task errors, you can see when it started, when it errored, and you can actually, it gives you the traceback of what happened. So, see here, this is what happened. It got passed in 3 as its add parameter, but it was in fact inspecting 2. So this is the exception that was thrown. This is your traceback. This is the worker that ran it. It is now in a failure state. So what we're going to do is we are going to add ourselves, because we know that 1 plus 1 is 2, and we are going to pass 2 on to this multiply. So there is this functionality called manually advance. Let me pull up that code real quick. Zoom in on this real quick. Okay, so right here, oh, back up, sorry. Forget where code is. Here it is. Okay, so manually advance. All this is doing is it's just notifying the listeners that, hey, either this task is in success or this data is available. So what we're going to do is we are going to manually advance oops, so we are going to say that add data is now available, and that data is 2. So that's the syntax, pretty straightforward. Again, all we're saying right here is that add data is now available for usage, and that data's value is 2. So we kick that off, and lo and behold, multiply 2 and 2 works, and it does in fact notify divide after it's completed successfully. So our workflow is now in a success state. Come back over here, and we can see that Smart Multiply did try again, and it got the right data. It completed it successfully. And come back over here, and we see that it, so we manually advanced, and now we notified listeners that add data 2 is available, and so Smart Multiply executes successfully. We notify its listeners of its results, and divide kicks off and does what it needs to do. So again, it's really cool functionality. Our workflow broke. We were able to manually fix it. We didn't have to revert anything. Again, though, I just want to make sure I'm clear that you can revert workflows if that is an option you choose to do so. It is not. It is still an option if you use a distributed pattern. So let's go ahead, and I'm going to clean up again for our final example here. Okay, so for the final example, I'm going to show how a persistent flow would work in distributed, and then I'm actually going to introduce a new task into the workflow while it's running. So let's go ahead and check out the code over here. Whoops, there we go. Okay, we don't need this anymore. So we have a keep alive flow. All this is doing, I have one task, and it sleeps, and every 5 seconds it calls this incrementer task, which literally just increments the value. So you'll see a value just plus 1ing every 5 seconds. Nothing too special about that. So oops, gotta import all the good stuff. Import. Oops. Oh. We are going to run. Oops, gotta spell import right. I am running this flow in a separate thread so we can add a task in the same Python shell. So that's what's going on right there. So task.create keep alive flow. T equals threading thread. We're going to do flow.run. We don't need any arguments. All we're doing is keep alive thread. Oops. Oops, oh, sorry, I forgot a keyword in there. It's been a while since I've used this library. That thread and target. That's the one. Okay, so let's go ahead and kick off that flow. So we're going to see it over here. Starting, sleeping, incrementing, going back to sleep, and yes, oh, actually, here we go. Give me 1 second here. Okay, sorry about that. Print statements, threading, not good stuff. So back to where we started. You can see right here, this is all it's doing. It's sleeping for 5 seconds and it's incrementing. If you look right here, you can actually see the results. Start at 1, now we're at 2, we're at 3. So again, you can imagine this being some sort of monitoring type job. Maybe you want to constantly check a database. It's really good for, you know, like social media notification type stuff. Anyway, so that's what's going on there. Yes, I did not set up my logger. I'm aware of that. Okay. So next thing we're going to do is we're going to, so I've already predefined a task right here. It's a decrementer task, and it's just going to decrement the value it's given. So it's going to be called at the same time incrementer is. So sleep 5 seconds, increment the value, and then in a separate task decrement the value. So let's go ahead and dec is going to be, let's get this, oops, sorry, 1 second, get decrementer task, okay, whoops, it is just not my day for typing, okay, and all we're going to do is we are going to add this task to the workflow. oops, yes, sorry, I forget. This task ID stuff right here is, again, a little bit of hacking. It's should be done by the first release, so try to just ignore that for right now. I am sorry about that. So flow.add our decrementer task. We go, and if we go over here, after the sleep is done, oh, check it out! Now we are incrementing and decrementing at the same time. So we actually have another task added to our workflow after the flow had started. Super cool stuff. Let's go back to Flower real quick. Our worker is online, in fact. And you can see our decrementer task is, in fact, getting called, as well as our incrementer task, our keep alive task, which is our sleep task, every 5 seconds. Let's go in here. Yep, I mean, it's a completely functional task. We have successfully modified a running workflow. Super exciting. Alright, so I'm going to go ahead and kill that real quick as my MacBook gets super hot. Alright, so that's a basic overview of distributed. There are so many more examples on our wiki of distributed flow stuff, as well as traditional patterns. We have docs on the GitHub, all sorts of stuff. So going back to the taskflow project itself, right now we're trying to get integration with a couple different projects. Right now we're focusing a lot on Cinder. We have some Nova stuff going on. Again, this is all on the wiki. If you want to see any of it, you can come check this out right here. Contributors, we have a weekly IRC meeting at 3 p.m. Central Standard Time on the OpenStack IRC. We also, or the OpenStack meeting IRC, we also have our own IRC, OpenStack State Management. If you guys want to check that out, we're on there all the time. We have a launchpad right here. We would love for people to contribute, ask questions, provide feedback, you know, whatever it is. We just want to get more people involved with the project. So feel free to email anybody if you have any questions. Check out the code, give it a try, and thanks for watching the video.